There's no thrill like discovery. The Discovery Channel. Explore your world.
Many real-world situations that model quadratic functions are data-driven. What happens when you are not given the equation of a quadratic function, but instead you need to find one? In order to obtain the equation of a quadratic function, some information must be given. Significant data points, when plotted, may suggest a quadratic relationship, but must be manipulated algebraically to obtain an equation. There are many applications of a quadratic function. One of the most important applications is finding the maximum or minimum value. Only here can we unveil the mysteries in deriving the equation of quadratic function and applications of quadratic functions.
Somewhere in a remote place in Baliling city is located a place believed to contain artifacts that contain mysteries in deriving the equation of a quadratic function and applications of quadratic functions. These artifacts are believed to have existed somewhere in the past. These artifacts not only contain surprising mysteries but also problems.
Mathematicians long time ago discovered ways on how to understand and derive these formulas. They said that these formulas can only be derived if given its zeros. At least 3 points in the parabola, or the sum and the product of the roots of the resulting quadratic equation. Now let us consider this example. Find the equation of the quadratic function having 3 and 5 zeros.
Hello, I am Professor Dean Mephistofeles, and I will explain the methods of deriving the equation of a quadratic function. First, find the equation of a quadratic function having 3 and 5 as zeros. Solution by walking backwards. Take 3 and 5 as zeros. X is equal to 3 and x is equal to 5. Let them be factors equated to 0. X minus 3 is equal to 0 and x minus 5 is equal to 0. Put them in a factor form. X minus 3 times x minus 5 is equal to 0. Then multiply this into using FOIL method. X times x is equal to x squared times x times negative 5 is equal to negative 5x. Negative 3 times x is equal to negative 3x is equal to negative 8x, and multiply this into negative 3 times negative 5 is equal to positive 15 until you arrive into a quadratic equation x squared minus 8x plus 15 is equal to 0. Then change the 0 into fx, then you will arrive to quadratic function fx is equal to x squared minus 8x plus 15.
In conclusion, these artifacts have shown 3 points to remember in deriving quadratic formula. Its zeros are given, at least 3 points in parabola are given, and the sum and the product of the roots are given.
There are many applications of quadratic function. One of the most important applications is find the maximum or minimum value. Let us consider the following examples.
Kim Allen has 300 meters of fencing material. One side of his garden is against a wall. What dimension of his garden must be considered for the area be maximum? Find this area.
Let W be the width of the garden and L be the length of the garden. P, or the perimeter of Mang Allen's garden, is equal to L plus 2W, or 300 is equal to L plus 2W. Solving for L, transpose L and 300, so we get that L is equal to 300 minus 2W. The area is equal to length times width. 300 minus 2W is times W. Finding the area is equal to negative 2W squared plus 300W.
Solving for the x-coordinate is equal to negative b over 2a. Substitute 300 to b to negative 300 and a to negative 2. So we can get negative 300 over 2 times negative 2. So we can find 75 meters. Width of Mang Anis garden is 75 meters. The length is equal to 300 minus 2 times the width of the garden, 75, is equal to 150 meters. Therefore, the area is equal to 15 times 75 is equal to 11,250 square meters.
In conclusion, to get the maximum value, formulate a quadratic function that will give a parabola opening downward, while, if the resulting quadratic function opens upward, the coordinates of the vertex represent the minimum value.
귀요미 초코머핀 한 조각 시켜놓고 고소한 우유